All right, let's get this show on the road. Hello, everyone. Hope you're well. Welcome to another edition of Math 1108. Where's everybody? All alone. Okay, so first, some announcements, I guess. We have a test coming up on the 14th. I think, so the date is definitely set in stone, but the topics are more or less more fluid, just whatever we get up to. So it'll cover whatever we get up to on Friday, which should just be some basic facts about sets. And I guess I'll put like not like a real mock test, but like a mock test on Gradescope, just so you guys can go in and just get used to doing stuff there, as well as, yeah, so there's that. So there's the test that's coming up pretty soon. Also, we do not have class tomorrow because we're on spring break for like one day, so don't show up tomorrow. Also, I know I didn't post the video lectures for the last lecture, maybe the last two. That's because I wanted to change something in the notes before I posted the video. I keep forgetting to change the notes. Every time I remember to post the video, I then remember, oh, you didn't change that thing in the notes, so the notes itself doesn't work. Okay, so that's what we have. I don't think I have anything else to say. At least I don't remember. Yes.
The 14th is a Sunday. Do we have it on a Sunday?
Yes, I believe so. Yeah.
Okay.
So that was intentional. It's been written in the syllabus. Anyway, all homeworks up to topic 7 would be due before the homework. So it's organized weird in the homework thing. They do it by these modules or stuff. But whatever gets you up to sets. Like here's a set, find the union, the intersection, blah, 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 stuff like that. So it's not going to involve counting or probability or anything like that. It's just going to, everything we've done up to like the basics of set theory. So just do all the homeworks up to that point. I can look through it and give you guys more details, stop exactly here, but I didn't check that before. Yeah, I think that's somewhat it. Yes, the homework is on Pearson. Pearson MyLabs. Your test is not though, so be sure to go to the right place. The test is not on Jupyter. It is not on Pearson. It is on something called Gradescope. Let's make sure I can see the chat here. Okay, so really today, the only order of business is to actually get through this example. We're actually going to do this one example 3 different ways. We're going to do it by hand because you're going to need the practice. It's also a very good problem, I think. As far as level of difficulty for the test goes, I think this is a very good measure. Some of the examples that I did, like the first 2 examples, I think were harder than I would put on a test. But this one is pretty much test level difficulty. So it'll be good practice for us to go through it. As well as I promised, we're going to learn how to do this on the computer. We're going to do this on Excel, and we're going to do it in Python. So hopefully you actually looked at all that stuff that I've been sending out like a month ago, a few weeks ago. So yeah, let's actually jump into it. So this was the last, yes, Colin? You have a question?
It's Steven.
Oh, Steven, yeah, what's up?
I'm just looking at the homeworks on Pearson, and there's like module 01 pre-homework, module 01 post-homework. So do we have to go all the way to?
Yeah, you have to do all of them. Do everything. The pre, the post, everything.
And we finish up to 6. Did you say?
You would finish at section 7.1 in our textbook. I don't know specifically what module that lines up with, but I could let you guys know.
Will we stop at 7.1 or?
Yeah.
Okay.
Yeah, so originally in the syllabus, it says that you go up to topic 9, but I'm going to stop at topic 7.
Okay, yeah.
The date is actually way more important to me than how many things we covered, actually.
Okay, yeah. I'm just trying to figure out like which one's 7 because it just says like module. There's like it's like hard to tell.
Yeah, I didn't organize the homework, so I really have to go in and look at it. I realize it's not done by section.
Okay.
But if you want, you can send me an email reminder, and then I'll send a mass email to the class, make sure that everyone knows exactly where to stop. But all homeworks from the beginning to that point would be due, I think, Saturday at midnight, if I recall.
And will we have all day Sunday to take the test, or do we have to take it at a certain time?
It starts at a certain time.
Okay.
If for some reason you definitely have a very good reason for you not being able to take it, then I'll have to make alternative arrangements and we'll have to set something up separately. Like I'd have to create like a different user account for you and some other stuff. But yeah, the date and the time is already in the syllabus. Yeah, so it's going to be on Gradescope. I'll probably send you guys just a fake test, not in terms of, oh, this is what your test is going to be like, but just in terms of getting you used to using it. Whenever it asks you to scan and upload something, you'll know what to do in that case, things of that sort. But let's actually jump into this. So this is the last question we want to solve. We're going to do it by hand. We're going to do it with Excel. We're going to do it with Python. So let's first do it by hand. So here we were told, let's actually read it. A plane carrying food and water to a resort island can carry a maximum of 30,000 pounds and is limited in space to carrying no more than 525 cubic feet. Okay, so that's the volume. Each container of water weighs 60 pounds and takes up 1 cubic foot of cargo space. Each container of food weighs 150 pounds and takes up 5 cubic feet. Hotels on the island will buy food for $16 a pound and water for $5 per pound. What is the optimal number of containers of each item that will maximize our revenue, maximize the revenue generated by the plane? What is the maximum revenue? We want to know this. Also here, I told you what variables I want you to use. A lot of times you'd have to choose your own variables, but I think just to make things easier to grade, I might actually just tell you what variables to use. So that's what I do here. X represent the number of food containers, Y represent the number of water containers, right? But normally what you would do is you would set up variables. Right. So this is like the pre-check, the pre-setup stuff. So we would go, all right, let X be the number of food containers. Let Y be the number of water containers. Okay, so normally you would do that. I actually gave this to you though, so you wouldn't have to write this. So one, you set up your variables. Usually the variables are going to be the things you want to look for. That's going to help you answer whatever problem they have, right? If you know how many containers, you'd be able to know how many things you should carry, right? Because that's what the problem is kind of saying. What is the optimal number of containers? You see that right here? So obviously the number of containers is important to me. So I set up variables to be the number of containers, right? So we have that. Now, what else do we do? Once we set up the variables, we make sure that we understand. And by that, I just mean organize the problem. Make sure you understand in your head what's going on. Oftentimes, this can be done via a table. So we know that there are a couple of things that were important in this scenario. We have food, we have water, and we have the max total capacity. So we called our food X. We called our water Y, so that's the number of Y. Right? There were two sets of requirements. There was a weight requirement. The plane can have a maximum of 30,000 pounds. And there's a space requirement and 525 cubic feet. So we have a weight requirement and we have a space requirement. And we can just put in the revenue here just to summarize everything in a table. $16 per container per pound. And this was $5 per pound. Oh, by the way, I want you to appreciate that we are tracking the number of containers, but they told us the revenue in terms of the number of pounds. You need to notice that it's not based on containers, based on pounds. So you'd have to figure out that. As well as, what else do we know? Each container of water weighs 60 pounds and takes up 1 cubic foot. Each container of food, 150 pounds, takes up 5 cubic feet. Right? So that's us just organizing everything in a table. Right? And so now we understand the problem, we organize it, we're going to set up the LP, which again is short for linear programming problem. So what do we want to do? We want to maximize. What do we want to maximize? Revenue. Call it Z equals, so it's going to be, notice looking in this column, no, not that, no, where am I? Looking in this column, the revenue column, right? That's what we want to maximize. So it's $16 per pound. So that's going to be $16 times 150 pounds. Is this blue hard to see? I feel like this blue is hard to see. The color palette on this thing got messed up and I can't find. I was making fun of this in the other class with the Apple and their whole think different thing going on. Maybe that blue would be nice. I forgot what blue I had before. So it's 16 times 150, which gives you the price per pound. And where's my phone? Okay, let's see here. 16 times 150, that's 2,400. So, and then I'm going to want 5 times 60. That's 2,400 X plus 5 times 60, I think is 300 Y. And so that's this, converting to pounds. Okay, make sure our units are all set up correctly. Yeah, so we want to maximize that function. That is our objective function. Subject to some constraints. So what are the constraints? We have a weight requirement. Looking in the second column in this table, 150 X's plus 60 Y's cannot exceed 30,000. See, that's the weight requirement. We also know that 5x plus y has to be less than or equal to 525. And this is the space requirement. Of course, we can't give them a negative number of containers. So we have our non-negativity requirements here. And that's it. That's all the information we have for this problem. Right? So that's the setup. Now you want to solve the LP. So remember the first thing, so now we're in those steps that I gave you guys, is to find the feasible region. Okay, so X, Y. We are going to go up here. We are going to, let's draw the first one, plug in Y equals 0. So I have X would be 30,000 divided by 150. Which is 200. And then if I plug in X equals 0, my Y would be 30,000 divided by 60, which is 500. So, my hand tapped the button just now. Okay, we're my finger tapped the power button. Okay, so now that's the line. Don't know why I made it so big. So this was 150x plus 60y. Is everything okay with you guys? Are you seeing my screen okay?
Yes.
Because it's my screen over here is spazzing out, so I don't know if you guys are seeing that. Is 30,000. Okay, and what else? Go to the next line. 5x plus y is 525, which means that if I plug in y equals 0, my x is going to be 525 divided by 5. It's 105. And if I plug in x equals 0, my y would be 525. So there. Now I'm going to that's 5x plus y equals 525. Now, let's see where we want to be. We want to be above the x-axis, to the right of the y-axis. And we had less than or equal to for these guys. I want to be below this line, but also below this line. That leaves us with a feasible region of in here, which which means we want to identify and find the corner points. Now, most of these are going to be obvious. The only one that's not obvious is that one in the top right corner-ish. So let's find that. That's actually step two. Step two is to find the corner points. So the only one we need to find, so we know that 0, 0 is 1. We know that 0, 500 is 1. We know that 105, 0 is 1. And so for the last, we're going to do the 150x plus 60y equals 30,000. And the 5x plus y equals 525. So now we want to actually solve that. So what I can do, this is equation 1, that's equation 2. Can multiply the second one by, say, minus 60. Minus 60 times negative 60. Call that equation 3. Then I'm going to add these. Adding equation 1 to 3, I would get, the y's would die. I would get minus 150x equals minus 1500. That would give you your x is 10. This would mean that your y is 525 minus 5 times 10. That looks right here. Which is 525 minus 50, which is 475. So the last one is 10, 475. We can put that in. So like I said, I do want you to put in the, I definitely want you to show what you're doing. But as someone mentioned last time, you can use a calculator to do these calculations. I actually, when I'm thinking about the timing for the test, I keep in mind the time it would take for someone to do this by hand. So if you're a slow test taker, you might say, oh, I can shave off a couple of minutes here. So if you have a calculator that can solve a system of equations, you can use it, but I need to know, I need to be able to read your work and know what your thought process is. So I need to know that you need to write down that you have identified this is something that needs to solve, and then you can go straight to the answer, right? By just saying by TI-89 or whatever. Right, so when writing out work, right? So, and that's fine. But in terms of how I expect you to be writing things out, I expect you to label your variables if I didn't give them to you. Organize your thoughts. I guess that's optional. You should definitely be able to write out this problem. And then I need to see that you drew the picture, you've identified the feasible region, you've identified the corner points, and I need to see that you know what you had to solve to find the corner points. Now, whether you actually solve that in a calculator, I don't care. But you should be able to solve it by hand, and I would give enough time on the test for anyone who wants to solve it by hand. But ultimately, that's what we have here. We have the corner points. So now we move on to the third phase, which is to test, which means we now have a bunch of corner points to check. So we have X, we have Y, and we have Z equals 2400. 2400X plus 300Y. And we have 4 possibilities. So 0, 0, 0, 500, 105, 0, and we found 10, 475. Okay. And you just want to plug them in. So we want to maximize our revenue. How do we do it, Captain? Well, we could stay home, not deliver anything. Revenue would be 0. On the bright side, we'd get a good night's sleep, which is priceless. Okay. But let's say, the boss doesn't accept that. He actually wants to make some money. So then you are going to go in and you're going to find whatever these numbers are. So the first one is going to be 500 times 300. It's going to be 150,000. Another possibility. 2400 times 105, 252,000. Another possibility. Five. 166,500. Do you guys agree? I'm doing I'm doing things on my phone, so you guys should double check me with that. Are we all in agreement that those are the numbers? Because so far it looks like this, if I typed it in my phone correctly, is what we want. Is anyone alive out there?
Yeah, that's what I got.
Okay, thank you for the sanity check. All right, so now we go to 4. And 4 is to just now answer the question. Make sure we give the people what they want. So we're going to go here, and what was requested? What is the optimal number of containers that will maximize the revenue, and what is the maximum revenue? So we want them to say the optimal number of containers. Optimal number of containers. Food, 105. Water, they don't need any water, 0. They don't need water, it's just food. Just give them food. We'll give them some hydrating food. They don't need water. Okay, but for us, that is the best thing. Why? Because now the max revenue that results from that is going to be 252,000. And that is going to be the answer. And so, at this point, you might be like, well, you know what? We can't not give them any water. We should be humanitarian. We should care. And someone is like, could make an extra 100,000. Oh, they don't need water. Like, forget them. Like, yeah, 150,000 versus 250,000. They're on a resort, right? They're on an island. Like, they're good. So let's not worry about it. So that is the optimal solution, at least by hand. Now, we could be crazy. We could be wrong. What we're going to do is now we're going to learn how to do this on in Excel and Python and double check our answers. So you guys can write down that answer. And yeah, check. We're going to check. So let's see, where are we? What do I want to do? Yeah, so I'm not going to be using Excel on the iPad. That is going to be, okay, so what I'm going to do is I'm going to attach, I'm going to connect this other tablet here. And yeah, so all right, let's see if we're crazy or not, and do this in Excel. So pretty much what we're going to do now, maybe I should write that down. We check this in Excel and Python. See class video. Because I'll probably put a part of your test where you'd have to do this, and it will be something where you can't really do it by hand, maybe like 3 or 4 variables or something. I'll ask you to do it in Python or Excel and like take a screenshot or something. So yeah, so make sure you check out the video whenever Jhevon gets around to posting it. Yeah, and so what we're going to do now hopefully you guys are seeing me in Excel. Maybe you guys are also minimizing me to the side of the screen and opening Excel on your own computers because you learn by doing. And you can tell me if you're having errors or anything, although I don't know how much time I'll have for troubleshooting with that. But I would be kind of trying to really make sure you're following along. Okay, so let's see. So you're all seeing my Excel screen, right? Okay, I guess like there's no answer. I'm going to assume someone's watching. So you go in, what do you need to do? You need to set up your variables. Okay, for us, this was X and Y. We're also going to want to set up our objective. This was to maximize Z equals. Now this we're really only typing for ourselves here. Excel doesn't actually need to know this, but I will need to know it as a human being to know what I'm looking at and where I'm going to be telling Excel to work on. Right, so let's go back to our original LP. We want to maximize 2400 X plus 300 Y. Okay, and we're going to be entering that stuff as well. So that's our objective, constraints. Now, there are tons of ways you can set this out. Some people like setting it out vertically. Some people like setting it out horizontally. You can make it colors, make it as flashy as you want, you know, put a little generic picture of, you know, two people in a business meeting pointing at a chart laughing, company logo in the background, all that good stuff. People like numbering their constraints. So constraint number 1, right? And we can actually type that. So 150x plus 60y, and I want that to be less than or equal to 30, 1, 2, 3. 30, 1, 2, 3. Constraint number 2, I want 5x plus y less than or equal to 525. Constraint number 3, I want my x greater than or equal to 0. Constraint number 4, I want my y greater than or equal to 0. So these labels are really just for me. And I can here I'm going to actually enter the constraints. So there's the left-hand side, there's the inequality, there's the right-hand side. And, you know, just kind of, so we can see the 3 separate things we set up. So there are 3 separate blah, blah, blah. Like, could do, I mean, I'm gonna go with gray in the interest of time. Can we do that? No, don't want to do that. Okay, so this is just me setting it up for human eyes, right? So now we're actually going to enter the data and have Excel actually help us solve this. So your answer is going to show up here. You know, optimal values will show up here. Optimal objective will show up here. And for cells, let's actually do maybe a light blue. And this is going to be relevant numbers / formulas entered into these cells. Just want you to actually know where we'll be entering commands. Yeah, so here's how we're going to do it. So this is just for your eyes to be able to see and talk about it. So you just set it up however you want. Maximize, you go into this cell. What do we want to maximize? You enter equal. That tells Excel I'm now going to enter a formula. And I can see right here, I want to maximize 2400 times what? This cell value right here, whatever that is. And if you click in that, blue was probably a bad color because now you can't see it. You'll see it highlights a blue 2 plus 300 times this cell right here, enter. So now you can see it's currently 0 because there are no values there, but that's the code I enter. You'll see the code up here. No, don't want to do that. Okay, so B2 and B3. So that's our objective. Now you're going to go down here and you're going to put in the left-hand side. So you say equals 150 times that value plus 60. I think I did something there. 150 times that value plus 60 times this value, enter. I want that to be less than or equal to 525, 30,000. I want 525 to be down here. Here equals, I want 5 times the X plus 1 times the Y, so I'll just click Y, enter. I want that to be less than or equal to the 525. I need my X, so here I'm going to be equal X, enter. I want that greater than or equal to 0. And I need my equals Y, enter, greater than or equal to 0. And you don't have to, technically you don't have to put in your non-negativity requirements. I'll show you where else you can do that. But if you just want to be safe, there are 4 constraints, including our non-negativity requirements. Okay, so that is the solver kind of set up. Now you're going to actually do the solver. Now the solver is under the data tab. Okay, the solver is going to be to the right here. Now, the reason it's there is because when I taught this in the class just before yours, I installed it, but you might not have it installed. So if you don't have it installed, you don't see it here. What you would do is you would go to File, you go to Options, you would go to Add-ins, you would go to Excel add-ins, you'd click Go, you'd click Check Excel Solver add-in. You'd click OK, and then this guy is going to pop up, usually to the far right. So that's what we're going to do. Now you click on the solver, and you're going to tell Excel what you want to solve. Now, if anything is filled in here, you just reset all, clear everything, and now we're going to go. Set the objective. You can actually type in the cell numbers here, or you can click this button and tell it where your objective should be, which is the formula we enter there. Click enter. I want to maximize, so I'm going to select maximize by changing the variable cells. Now this is where your variables are. I'm going to click that, highlight those cells, click enter. Now it knows that that's where it's manipulating the values. It's going to keep changing these values in those cells until it hits an optimal value. Now you're going to go to the constraints. You're going to add constraints. The left-hand side here, the inequality goes here, which you would have tons of options, and the right side goes here. So cell reference, I would click this. I want that to be less than or equal to this, add. Next one, this, I want that less than or equal to this, add. Next one, I want this greater than or equal to this, add. Next one, I need this greater than or equal to this, add. Now all your constraints are added. Click cancel, you'll see them pop up here. These last 2 are our negativity requirements. We can add them, we can change them, we can delete them. However, notice that here there's a box that says check to make unconstrained variables non-negative. So this is basically what it was saying, that if any variable that I don't tell Excel what values it can take on, assume that it's greater than or equal to 0. So I didn't actually have to put in these 2 constraints. I could have just checked that box and it would have done the same thing. Now, the name that I mentioned to you before of how the more sophisticated way to solve the problems than we've been doing it, it's called the simplex method. You would select the simplex method, and yeah, you solve. And you'll notice, hey, that actually matches what we thought. 105 food containers and 0 water containers for a max revenue of 250,000. So we weren't crazy. You can also generate all sorts of reports, which might be important for various reasons. But I didn't actually go into any of that with you, so you don't need to know that. You will need to know these answers right here and be able to pick those out. And so that's how you'd kind of do it in Excel. I sent you guys a couple of other YouTube videos as well to see how some other people do it. But yeah, I guess you can rewatch the video and make sure you learn this. Now, let's go to probably okay, so now you guys are seeing my entire screen, I think. So let's actually do this. So told you guys how to install Python and Anaconda and all that stuff. And you could also do this in collab.research.google.com. But you can, once you do that, you can be like Anaconda. So first of all, you need to make sure that Gurobi is installed. So you go to the terminal, you can do conda install -c Gurobi, press enter, it'll install it for you. I can show you guys what that looks like real quick. This is what you should see, what you should expect. Just gonna ask you to, now normally what happens, it tells me here my package is already installed. Normally what happens is the message would come up here to say, do you want to install this, yes or no, Y/N. You press Y, you press enter, and it's going to install it. But I installed it in the earlier class, so you guys aren't gonna see that. Now, what we're going to do is you would go here, wherever you saved it, you can just look for it here, go to the Anaconda Navigator, right? Right. Oh, I already launched that too from the earlier class. Don't want 2 instances of that. Okay, so you'll look like this. And I told you guys how to install your Jupyter Notebook, launch. It'll launch in a browser, whatever your default browser is. And this is a file that I sent you a while ago in an email. And it has the code that you will need. So you actually won't really know how to program. You're just going to modify code that I already gave you. I gave you 4 examples of code. The one that's going to be relevant to us is the first example. So you can actually just ignore all the other ones. But if you don't install Gurobi first, like I showed you, it'll give you an error when you try to run these. So let me go all the way to the bottom and put it in, add one. By the way, when you go to Jupyter Notebook, it's not going to look like this. I installed a custom theme, dark theme, makes me feel like a hacker. But when you install the default, is a very light theme. It's going to look more like Colab. And that's that. So now, here are where the variables, you create the variables. You'll notice that the comment is there. So you just modify it. You rename that X, rename that Y. There is no third variable. LB stands for lower bound, can set lower bound equals 0. That gives me the non-negativity requirement, so I don't have to enter those. You could also set upper bounds as well with UB. Then your constraint is going to be here. Notice that we want to maximize, that's why that's here. You would put minimize in this case if you want to minimize, and you're going to put in the constraint in this location. So I'm just going to modify that. I want to do 2400 asterisk X plus 300 Y. That's the thing I want to maximize. Now you go down to your constraints. Computer scientists love starting to count from 0. We'll just count from 1, constraint number 1. Copy that, constraint number 2. So now I'm just going to modify these. We're actually going to type in the constraints. So our first constraint was 150 times X plus 60 times Y. less than or equal to 30, 1, 2, 3. Then the second constraint, 5x, 5 times x plus y less than or equal to 525. That's the second constraint. You don't have to know what any of this is. You don't have to be a programmer. Like I gave you the code, I gave you the script. That's all you need really, and you just modify it, right? That's what real hackers do anyway, right? They Google everything and just paste the code in, and if they can't figure out a password, they call up and pretend, oh, I work in this office and I forgot my password. Can you help me reset it? And that's how they really do it. But yeah, so you don't really need to know that. Now you run it. You can either click that, or you can hold down Control and Enter, or Shift and Enter. The moment it finishes running, it'll tell you a number will appear here. While it's running, an asterisk might appear there, but this quote is going to be very quick, so you probably didn't even notice that. Scroll down, there is our answer. X105, Y0, optimal revenue 252,000. And there we have it, voila. So that's how we solve it in Python. Just use the code I gave you and modify the code to fit your needs. And this is sort of what it's going to be like in the project too. If you have to do the project in Python, don't really have to be a programmer. Like if I ask you anything, just Google, how do I do this? Copy the code, modify it to fit what you want. So it's more like a hacking project than a coding project, but that's that. And since we are over time, I will actually just stop there. So yeah, no class tomorrow. We'll start sets on Friday. That'll be the last topic for the test, which is on the 14th in Gradescope. I'll post the videos. I will tell you exactly what module to stop on the homework. And I think that's it. So thank you for your time and attention. We will end right there, and I will see you guys in the next one. Ciao.